And basically, it's about system of equations. So we need to review some, basic facts that you learned in your math class. Any equation of a line can be written in this form, y equal to mx plus b, where m represents the slope of the line and b is the y-intercept. 1 second, people are still coming in. Sarah, Lee, Samantha. Okay. All right, this is why I don't like these late attendants. They keep interrupting me. It's another one. Plot. Okay, so slope of the line is what this m is, and b is the y-intercept, the point where the graph meets y-axis. Now, these are basic information you learned in your math class, but I'm going to quickly go over the slope formula because at least one of my homework questions asks you to use that. The slope formula means if you know 2 points on the line, then you can find the slope of the line by using slope formula. So let's say this point is 1, 2. This point is 5, 7. Then slope will be given by the y2 minus y1, 7 minus 2 divided by x2 minus x1, 5 minus 1. And so that's equal to 5 over 4. So slope is 5 over 4. Slope is usually a fractional number. Slope represents how steep the line is. That, the line gets steeper, the slope will be larger. Anyway, the point that we need today is the fact that any line has, the equation of any line can be written in this form. And if you write it in that form, the m is the slope and the last number is the y-intercept. So let's do this example. 2y minus 3x equal to 10. It says find the slope and y-intercept. Too many people are coming in late today. Okay, so let's do this problem on the board. 2y minus 3x equal to 10. What you need to do is rearrange it in the form y equal to mx plus b. And that means I had to add 3x to both sides to move the 3x to the right side. I had to get the y by itself on the left. So I move the 3x over. Then I get 2y equal to 3x plus 10. I need to get the y by itself. So what's the next thing I need to do?
Divide by 2.
by 2, right? So divide both sides by 2. Now you remember that you can do anything to both sides. So that gives me y on the left, and this fractional expression can be split. You know, it's the same as, let me explain quickly. If you have two fractions, 1/3 and 4/3, then 3 will become common denominator and numerator is 1 plus 4. And same thing can be used backwards. If you have 1 plus 4/3, it can be split into 1/3 plus 4/3. So that's what I'm doing. 3x plus 10/2 can be written as 3x/2 plus 10/2. So 3x/2 is same as 3/2 times x plus 10/2 is 5. So now we have y equal to mx plus b form. So this is the slope. So slope m equal to 3/2 and y-intercept, sorry, m equal to 3/2, y-intercept, this number is the y-coordinate of the y-intercept. So the full coordinates of the y-intercept will be 0, 5. X-coordinate of the y-intercept is always 0. Alexis Alvarez. All right, too many students came late today for some reason. Now remember, if you have only one lateness, that'll be forgiven. If you have more than one lateness, you lose the reward. So you don't want to be late too often. You don't want to lose your rewards because it's a big deal. As I explained on the first class, if you get the rewards, your grade usually changes from B to A or C to B. So it is important to get that reward. If you're late more than once, you lose the reward. Okay, so let's see. Let's skip the warm-up exercise. This is all basic stuff. I'm sure you know that already. Parallel lines. We need to understand, everything about lines, pair of lines. If you have two lines, what are the possibilities? That's what we need to understand here. So let's understand parallel lines. If two lines, if you extend the two lines and if they never meet each other, that's when we call them parallel. So parallel lines never meet each other, no matter how far you extend it. Now, if two lines are parallel, then the slopes will be equal. Now, let me explain quickly why. Because slope is a measure of steepness. So for two lines to be parallel, they have to have same steepness, exact same steepness. Only then they will be parallel. So therefore, slope will be equal. The two lines have to have same slope to be parallel. That's the point. Okay, so now let's understand what are the possibilities for pairs of lines. If I give you a pair of lines, then they can be one of the following. They can be intersecting. If they intersect, it'll be at one point. Lines cannot meet at more than one point. They can be parallel, then they will never meet each other. They can be coincident, which means one line falls on top of the other. Now that's a possibility too. So we need to be able to identify, for two lines given to us, we need to be able to identify whether they're going to meet at one point or parallel or coincident. So to do that, first, there is a direct way of doing it. Let's understand that. The slopes for the two cases, parallel and the coincident, the slope will be equal. You can see if they're coincident, then they have same steepness, so the slope will be equal. Also, if they're parallel, slopes will be equal. So one thing you need to check is the slope. If the slopes are equal, then they are either parallel or coincident. It's one of those two. Then you need to look at the y-intercept. We know how to find slope and y-intercept for both. If the two lines are coincident, then the y-intercept will be also equal, right? The lines are coincident, one falls on top of the other, then they will meet the y-axis at the same point. But if the lines are parallel, then the slopes, y-intercept will be different. Okay, so that means two things to look at, slope and y-intercept. If the slopes are not equal, then immediately you can conclude that they're intersecting, right? If the slopes are not equal, they are going to intersect. If the slopes are equal, then you have to look at the y-intercept. If the y-intercepts are also equal, then they are coincident. If the y-intercepts are not equal, they are not coincident. They are parallel. All right, so these are the rules. Let me repeat that again. If slopes are not equal, immediately you can conclude they're intersecting. If the slopes are equal, then you have to compare the y-intercept. If y-intercepts are also equal, they're coincident. Otherwise, they're parallel. Okay, so let's do an example. This problem says determine whether the following pairs of lines are parallel, coincident, or intersecting. Okay, so I'm going to do just one of those, part B. So let's clear the screen. Okay, so what we need to do is find slope and y-intercept. So take the first line, 3x plus 2y, 3x plus 2y equal to minus 5. And I'm rearranging it. So 2y equal to minus 3x minus 5. Divide by 2, y equal to minus 3 over 2x minus 5 over 2. So we can see the slope and y-intercept, minus 3 over 2, minus 5 over 2. Now take the other one, 2x minus y equal to minus 1. I'm moving the x to the right side, then I get minus y equal to minus 2x minus 1. I'm dividing by minus 1, y equal to 2x plus 1. Minus divided by minus is plus, so they both become pluses. Okay, so the slope is 2 and y-intercept is 1. Now, so that means the slopes are not equal, minus 3 over 2 and 2. So that means what? They're intersecting, right? So if the slopes are not equal, then they're intersecting, and that's your conclusion. Okay, I want you to do this part C, just the part C only. On whatever paper you have, and then tell me the conclusion. Anybody has a conclusion?
Yeah,
Okay, what is it?
they're parallel.
Okay, one student says parallel. Anybody else?
Yeah, they are parallel.
I think they are coincident.
Very good. Coincidence is right. Parallel is wrong. Okay, let me show you why. I'm rearranging the first equation, y equal to minus 3x plus 6. Okay, so y slope is minus 3, m is minus 3, y-intercept is 0, 6. And now take the second equation, 2y plus 6x equal to 12. Rearranging it, 2y equal to minus 6x plus 12 divide by 2, y equal to minus 3x plus 6. Can you see that slope is minus 3, y-intercept is 6. So the slope and y-intercept are matching. That's when they are coincident, right? So these two lines are coincident. Only if the slopes are matching, don't come to conclusion that they are parallel. If slopes are matching, that means you have to look at the y-intercept to see if they are coincident or parallel. Okay, so now there are questions like this in your homework. So that's how you do it. Okay, now we're going to go into point of intersection of a pair of lines. Two lines, if they're parallel, then there's no point of intersection. If they are not parallel, then there will be one point where they will be meeting. And this point is what we need to find. The point is actually important, the point where the two lines meet. Let's look at this example. 2x plus y equal to 6. It says find 3 solutions of the equation and sketch the graph. Now you did this in the last class, so you know exactly what to do. 3 points on the line on the graph would be 0, 6, 3, 0, 2, 2. You know, I found them by plugging in different numbers. If you remember from last class, you can plug in any number for x and solve for y. Then you have a pair that'll be a point on the graph. Or choose any number for y and solve for x. So I chose 0 for x and 0 for y, and then 2 for x, and found 3 points. And you plot them and join them, that's your graph. Now, all right, this problem says verify that -2, 3 is the point of intersection of the lines whose equations are 3x plus y equal to -3 and x plus 2y equal to 4. Okay, the -2, 3, if I can verify that -2, 3 is a point on first line by simply plugging in, right? If it satisfies that equation, then it's going to be on the graph. All right, so I'm looking at the first equation, 3 times, plug in x equal to -2 plus y is 3. So the question is it equal to -3? I'm putting a question mark on the top of the equation symbol. Okay, simplify the left side. 3 times -2 is -6. -6 plus 3 is -3. So it is equal to the right side. So therefore, that concludes that from that we can conclude that -2, 3 is on the graph of 3x plus y equal to -3. Now let's plug it into the second equation. X plus 2y equal to 4. So -2, plugging in x equal to -2 plus y equal to, y is 3, so 2 times 3. Our question is it going to be equal to 4? -2 plus 2 times 3 is 6, so 6 minus 2 is a 4. So 4 equal to 4 is true, and therefore -2, 3 is on the graph of x plus 2y equal to 4 as well. So this point is on both lines. So there is only one point that can be on two lines. That would be the point of intersection. So therefore, this must be the point of intersection. That's how you verify that certain point is the point of intersection. Plug it into both. So the point of intersection has to be the point on both lines. So there will be only one solution when two lines, there will be only one point of intersection. So therefore, there will be only one point that would be point of intersection. So our goal next is finding the point of intersection if the lines meet. And when we find the point of intersection, we should be able to tell if the lines are not meeting anywhere. So We're going to learn the process of finding the point of intersection if the lines meet. And this process also will be helpful to determine whether the lines are parallel, coincident, or intersecting. So we will be able to answer the question of parallel, coincident, or intersection in another way, which is by using the process of finding point of intersection. So we're going to understand that next. This point of intersection, let's go back to this. The point of intersection -2, 3. -2, 3 is the point of intersection, means -2, 3 is a point on this graph as well as on this graph. So the point that it belongs to both lines is the point of intersection. So to find that point, so the point is actually the solution of both equations. So is there any way we can find solution of both equations? If we can find it, then we can find the point of intersection. Here in this problem, the point of intersection was given, and then you are asked to verify that it is the point of intersection. Our goal next is to find the point of intersection. So before learning the technique of finding the point of intersection, let's think about the number of such points. See, this 2 -2, 3 is a solution of both of these equations. It satisfies both. So point of intersection has to be solution of both equations, a pair of number that will satisfy both equations. That's what point of intersection will be. So when it comes to point of intersection, or when it comes to solution of the system of two equations, there are three possibilities. If the lines are intersecting, then there is one solution, right? One pair that will satisfy both. In that case, we say that the system is consistent. There is a solution for both equations. There is one pair of number that will satisfy both equations, only when the lines are intersecting. If the lines are parallel, then there will be no point of intersection, and therefore there will be no solution for both equations. In other words, there will be no pair that will satisfy both equations if they're parallel. If the lines are coincident, then what happens? Do we have a point of intersection or not?
All the points will be points of intersection.
Exactly. All the points are point of intersection. All the points on one line are also on the other one. That means every point on the line is a solution for both. So that's when we say there are infinite solutions, because every point on one line is also on the other line. So there are solutions and there are infinitely many. So if there are infinitely many solutions, we say that system is dependent. Okay, so there are some key words here you need to remember the meanings of. If the lines are intersecting, system is consistent. System of equations is consistent. If the lines are parallel, then there are no solutions for the system, and we say that the system is inconsistent. If the lines are coincident, then there will be infinite solutions. We say the system is dependent. All right, so we have consistent, inconsistent, dependent. These are the words for the system of two equations. The same concepts apply for system of three equations, four equations, but those are beyond the scope of this class. We are not going to be discussing system of three equations and four equations. We're going to just do two equations. Okay, so these are the key ideas you need to remember. If you remember these pictures, the pictures tell you everything. Now, the next goal is to find the point of intersection, which would be solution of both equations. To find it, there are three methods. I'm going to explain all three methods, and then I'll explain which method is better than which and all that. And you're going to have to know all three methods of finding solution of system of two equations. First method is called graphic method. Graphic method means we graphically find the point of intersection. So we graph the actual lines on coordinate planes. So here's the coordinate plane. We can graph these two lines on this plane and then find the point of intersection. So I'm going to do this particular problem on the board and show you how to find the solution by graphical method. So I'm going to copy this picture. Okay, and now we can graph this equation on that graph paper. So let's take 4x. First equation is 4x minus y equal to 4. 4x minus y equal to 4. So to graph it, I'm going to find 2 points. All we need is 2 points. So if I plug in x equal to 0, I'm getting negative 4 over the y. That's going a little bit beyond our graph paper. That's okay, I can handle that. If I plug in y equal to 0, then I'm getting x equal to 1. So 0 minus 4 is 1 point, 1, 0 is another point. 0 minus 4, minus 1, minus 2, minus 3, minus 4 is down here outside the graph paper, but I can still use it. 1, 0 is the other one, x equal to 1, y equal to 0. So I join them by a line, then that'll be my graph. Okay, it's that's my graph. And let's go to the other one, x plus y, x plus 2y equal to 10. Sorry, I have to pick up the pencil. X plus 2y equal to 10. Okay, I can find 2 points, x equal to 0, y equal to 5. If I choose y equal to 0, x is 10. X equal to 10, can we find that? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yes, so 10, 0. So 0, 5 and 10, 0 are the points on this graph. 0, 5 is 1, 2, 3, 4, 5 right here. And 10, 5, 10, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 right there. So I'm going to join them to get the second graph. Okay, so they seem to be meeting right here. The coordinate seems to be 2, 4. 2, 4. So 2, 4 appears to be solution. We can verify that by plugging it into both. If I plug it into the first equation, 4 times 2 minus 4, 8 minus 4 equal to 4. So it does work out on the first one. Let's plug it into the second one. X equal to 2 plus 2 times y, 4, and that's equal to 10. So it does satisfy the second equation as well. So we found the solution. It's 2, 4. So this is called the graphical method. Now, this method is not great. There are various issues. Anybody recognize an issue with this method? There are 2 issues. You should be able to recognize them. So, anybody? This method may not work in all the situations. What are the situations where it may not work?
Parallel.
If they're parallel, well,
Or if they meet too far away from the 0.
far away from the origin. Yes, exactly. 2 lines may be meeting, but they may be meeting far away from this board where, so something like this. I'm going to draw on the same graph paper. One line is this, the other line is almost parallel, but they're not meeting right here. My line is too thick. Anyway, they're not meeting within the graph paper. That's our problem. So that can happen. They may be meeting somewhere, but if they don't meet within the graph paper, we cannot read the coordinates. That's definitely one problem. Very good. So one student identified that problem. Anybody else identify the other problem? Okay, let me explain. Let's say I have two lines. So here's one line, and here's the other one. They're meeting somewhere, but they're not meeting at one of the grid points of the graphic paper. So I can't read the coordinates. Basically, they're fractional numbers. So if the numbers are fractional, we cannot read easily. It's extremely difficult to read them because the graph paper is designed to only have the grid points with the whole numbers as coordinates. So if the lines meet at one of the corner of the grid lines, then we can read. Otherwise, we can't read the actual number. So if the numbers are fractional, this method will not work. So those are the two main issues. So for that reason, this method is not very popular. But I will still give you problem on homework. You still have to know these methods. There will be problem on the homework. There will be problem on the test, asking you to do the problem by graphical method. Now, we don't need to do the warm-up exercise there. It's I'm sure you understood from my work. We just did this warm-up exercise 3. So now the point of intersection is the solution of both equations. I already explained that. So that means we can find that point by solving the two equations simultaneously. Simultaneous solution, the method is called elimination method, one of the methods. So graphical method is the first one, which is to graph and find the point of intersection. The second method is called elimination method. In this method, we will be finding the actual solution of the equation by using a certain process. And let me explain that process. There's a fact about system of two equations that's going to help us find the point of intersection. And so I'm going to explain that fact first. If you have two equations that will, let's say the two equations meet at a certain point. I'm going to just use, I'm going to use, show a picture here. Let's say one line, one equation, let's say this is 2x plus 3y equal to 1. And you have another equation, you graph that, and it meets this line. And let's say that equation is x minus 2y equal to 5. I'm just making up some equations. Let's say those are the equations. Then this point is the point of intersection. The fact that we're going to use is this. If I add a multiple of one equation to the other, so let's say x minus 2y equal to 5, 2x plus 3y equal to 1. If I add any multiple of this, 2 times this, to the second one, just anything, any operation like that. So let's carry it out. 2 times x, here's 2x, this is 2x. I'm adding the two equations after multiplying by 2. That gives me 4x minus 4y plus 3y, 1y equal to 10 plus 1, 11. This is the new equation I get. I'm just illustrating the idea. I have a new equation, right? This new equation, if you graph it, it will go through that same point of intersection. That is the fact. 1 second. Someone just came in. Layla. 7. So if you add a multiple of one equation to the other, the new equation will go through the same point of intersection. So all the new equations you generate this way, if you add another multiple of second equation to a multiple of first equation and get a third one, that third one will also go through this. It'll be another line, but it'll go through the same point of intersection. So all of them will go through the same point of intersection. That's the fact we're going to use. So this means we can get a new equation by adding a multiple of one equation to the other, and that new equation will go through the same point of intersection. Means by using the new equation, if I find the point of intersection, then it will be same as the original point of intersection of the original equations. So what we will do then is we will add a multiple of one equation to the other in such a way that one variable will cancel out. And then you will get an equation with only one variable, which will give you the solution right away. So that's the technique. Since we know that a sum of a multiple of one equation to the other will give you a new equation whose solution will be same as whose point of intersection with any of the other equation will be same as the point of intersection of the original equations. So therefore, we can generate new equations whose points can be easier to find. So that's what we're going to do. It's called the elimination method. So I'm doing this first problem, example 6, number A. So let me clear the screen, clear the board here. And I'm copying the two equations now, 2x plus 3y. Two x plus 3y equal to 1 minus x plus y equal to minus 3. Now, the process is to generate new equations using by using a sum of by doing sum of multiple of both or one. You can do any of those. I can multiply any one by any number and add to the other. So I'm going to do that in such a way that one of the variables will cancel out. So look at the first equation. It has a 2x. Second equation has a minus x. So when I add these two equations, I want the x to cancel out. What number should I have in front of the x in the second equation? Already I have a minus. What number should I have there so that when I add the two equations, x will cancel out?
Should be minus 2x.
Right, I need a minus 2 there. I already have a minus, so I need to multiply by 2. So that's what I'm going to do. Multiply second equation by 2. Then I'll get minus 2x plus 2y equal to minus 6. You have to multiply both sides though. Okay, if you multiply both sides, the equation is still the same. You're not changing the equation. I'm copying the first equation on top of that. And now I'm going to add both equations, both sides of both equations. The x's will cancel out. I have 5y equal to minus 5. Minus 6 plus 1 is minus 5. Divide this by 5. I get y equal to minus 1. I have a new equation, which is y equal to minus 1. Y equal to minus 1 will also give you a line, but that's a horizontal line, if you remember from your basic math class. Y equal to a constant means if you graph it, let me just show you quickly. If you want to find pairs of numbers, that will be on this line. 0 minus 1 is on that line. 2 minus 1 is on that line. X can be anything. As long as y coordinate is minus 1, it'll be on this line. So let's graph that. 0 minus 1. 0 minus 1 is right here. 2 minus 1 is right here. And 3 minus 1 is on that line. 3 minus 1 is right here. You can see what happens. It's a horizontal line. So the y equal to constant will be horizontal line. Well, we don't care what the graph is, but the point is this line, whatever these two lines intersect at, if these two lines are intersecting here, this y equal to -1 goes through the same point of intersection. But that tells us that the y coordinate of that point is -1, right? That's all that matters to us. The y coordinate of point of intersection has been found. It's -1. So we found the y coordinate. This line is y equal to -1. That means every point on this line has y coordinate -1. So therefore, point of intersection has y coordinate -1. So how do we find the x coordinate? Plug in the y equal to -1 into the original equation, either one of those. You will get the same x value from either one. I'm going to plug into the first one. 2x plus 3 times -1 equal to 1. 2x minus 3 equal to 1. Adding 3 to both sides, 2x equal to 4, x equal to 2. So x equal to 2 is the x coordinate of the point of intersection. So now we have found the point of intersection as 2, -1. So that's how you find it. You add a multiple of 1 to the other in such a way that that one variable cancels out. Okay, doesn't matter whether I eliminate x or y. No, it doesn't. No matter what process, how you do it, the final solution will be the same because the point of intersection is the same no matter what. So if I want to eliminate the y instead of x, what number should I multiply by and which equation? I'm still doing
Multiply the second equation by -3.
second equation by -3. Very good. As you can see, second equation has 1y, and I need a -3y there. So I need to multiply it by -3. That's how you do it. Okay. Moving to part B. So let me clear the board, and I'm going to do it with your instruction. You tell me what to do. I'm copying the problem right now. 3x. Oops. I keep forgetting to pick up the pencil. Okay, 3x minus 2y equal to 8, and 5x minus 4y equal to 13. Okay, looking at first equation, for x has 3 in the first equation, 5 in the second equation. So that's going to be harder to eliminate. This is called elimination method because you are eliminating one of the variables. But can you see that the second variable y is easier to eliminate, right? What number should I multiply the equation by? Which equation?
First equation by -2.
First equation by -2. That's right, very good. -2 times first equation. You will see in a minute why that works. I get -6x plus 4y. -2 times -2 is +2, equal to -16. And now I'm copying the second equation as is. And now you can see why we did that, right? Because second equation has -4y. I need to get +4y here. To get +4, I had to multiply by -2. That's what we did. So add the equations. -6x plus 5x is -x. Y's cancel out. -16 plus 13 is -3. So therefore, x equal to 3. So we found one solution. And plug that into either equation to find the other one. I'm going to plug that into the first equation. 3 times 3 minus 2y equal to 8. That's 9 minus 2y equal to 8. Minus 2y equal to -1 when I subtract 9 from both sides. So y equal to half. So our solution is 3, half. Okay, let me ask you a question. Instead of eliminating y, suppose that I want to eliminate the x. I can do it, even though the numbers are not easy to work with. We can still do it. Anybody see what numbers I should multiply the equation and which equation?
You can multiply the first one by by -5.
First one by -5 and
And
The second one by
And this by
3.
about
second one by 3, right? I have to multiply both now. That's the only way. Multiply first one by -5, second one by 3, or first one by 5, second one by negative. Either one of those has to be negative, right? So if you do that, then x's will cancel out. So I don't need to show you that. It looks like everybody understand it. Very good. So let's proceed to discuss the third equation. X minus 3y equal to 4 and y equal to 2. The second equation doesn't have an x in it. Okay, that means what? That means we already know the y coordinate, right? The elimination is unnecessary now. The y coordinate of the point of intersection is 2 from the second equation. So I just have to plug that into the first equation. So x minus, just plug in y equal to 2 into the first equation. That gives you x minus 3 times 2 equal to 4, and x minus 6 equal to 4, so x equal to 10. So the point of intersection, the solution of the two system of equation is 10, comma 2. That would be the point of intersection. The solution of the two equation would be the point of intersection. So that's how you do that one. Moving on to Womack's exercise 4. It says solve this system by elimination method. Okay, so that looks horrible, right? I know you don't like the fractions. But fortunately, there's a way to eliminate the fractions. And you can work with the fractions if you're comfortable with that, but I doubt that, not too many people are comfortable with fractions. So we will learn to eliminate the fractions. Okay, can somebody tell me what number I should multiply the first equation by so that all numbers will become whole numbers?
with 6.
Yeah, that's right. Looking at the two denominators, denominator of the first equation is 2, second equation is a 3. You can use the product of them. Just using the product will work, but product can be a huge number. So really you should use the least common multiple. Now, I'm not going to get into explaining all that. Least common multiple is basically the smallest number that is divisible by both of these numbers, to both of the denominators. In this case, that is going to be 6, 2 times 3. But in other cases, that number will be smaller than the product. But in any case, if you don't understand the least common multiple, you can just use the product. So I'm going to multiply both first equation by 6. So 6 times entire equation. Basically, I'm copying the equations first. Half x plus 1/3 y equal to 3. And the second equation is 1/4 x minus 2/3 y equal to -1. So I'm multiplying this one by 6 and the second one by what number?
12.
12, right. So let's do that. 6 times half is 3. So 3x plus 6 times 1/3 is 2y. 6 times 3 is 18. Now remember, you have to multiply both sides. Second equation, 12 times 1/4 is 3x minus 12 on the side. I'm going to do 12 times 2/3 for those who have difficulty with fraction. The 3 divides the 12 into 4. So 4 times 2 is 8. 8y equal to -12. So now there are no fractions. So you can always convert the entire system to a new system with whole numbers. The new system will have the same point of intersection because we didn't modify, we just multiply both equations with numbers. So they'll have the same point of intersection. So by solving these, you can find the point of intersection. Okay, I don't need to proceed to solve this. You understand how to solve them. Just answer my question. What number should I multiply the first equation by to eliminate the x?
-1.
Negative one. Negative one, that's right. You can multiply either first equation or second equation by -1 and then add them up. So no matter what you do, whether you eliminate x or y, the final answer will be same. The process can be different, answer will be same. Okay, so let's go to the next question. This elimination process we just learned can be used to determine whether the system is coincident, parallel, or intersecting. Okay, so let me show you what happens. If the lines are going to be parallel, see, only if the lines are intersecting like this, then there is a solution for it, right? If the lines are going to be parallel, then there will be no solution. They will not meet anywhere, so there will be no solution. When the lines are coincident, there will be solution, but there will be infinitely many. So we're going to see how to recognize these three different situations in this elimination method, in this process. So I chose this equation, example 7, to illustrate one of those. 2x minus y equal to 5 and 4x minus 2y equal to 8. If I try to solve this, now, first we can verify that they are not going to be intersecting. See, the slope, find the slope of the first equation, y equal to 2x. So it's 2 is the slope. And second one, if you find the slope, that's also 2. So slopes are equal. And y-intercepts are not equal. So if you use that old method we learned, these have the same slope and not same y-intercept, so therefore they're parallel. So these lines are parallel. We can, using the technique we learned before, comparing slope and y-intercept, I found that they're parallel. Now, what will happen if I solve them by elimination method? So they're parallel means there is no solution, right? If there's a solution, then we can find it by this elimination method. So let's apply the elimination method. Let's try to eliminate the x. What do I multiply first equation by to eliminate
-4, -2.
-2. -2. So I'm writing -2 times first equation, which is -4x, plus 2y equal to -10. And second equation, I'm just copying down as is, and I'm going to add the 2, and x's cancel out. The y's are also canceling out. I'm getting 0 equal to -2. Something invalid is what I'm getting. That happens when there are no solution. So when the system, so this tells you that the system is parallel. The two lines are parallel. I'm not finding a solution. I'm finding something invalid. So the fact you need to remember is this. If the solution process, if this elimination method leads to no solution, but an invalid equation, it results in an invalid equation. That indicates that the system has no solution, so the lines are parallel. Okay, so that means the conclusion is this. No solution, which means inconsistent, right? The word is inconsistent when there are no solution. And the lines are parallel. So the question can be asked in different ways. Sometimes the problems will say, I determine whether the system is consistent or not. So in this case, your conclusion is inconsistent. If they say, determine whether these lines are parallel or coincident or intersecting, then your conclusion is parallel. So depending on the question, you had to answer by using the correct word. So the problem in this particular problem, it says solve the pair of equation. So that means we found that there are no solutions. So our conclusion will be no solution or inconsistent, whichever word is appropriate. If they talk about whether the lines are parallel, coincident, or intersection, your conclusion is parallel. Okay, going to the next example, example 8, it says solve the pair of equations. So I can see that the slope of the first equation is half. Slope of the second equation is also half. So the slopes are matching. And y-intercepts are also matching. I can see that. I mean, you know how to do that, but I can do it in my head. The y-intercepts are also matching. So that means these lines are what kind? Slopes are matching, y-intercepts are matching.
They're
Coincident.
consistent.
Consistent is not the word.
They are
The solution?
coincident.
Coincident.
They're coincident. They are falling on top of each other. That means there are infinite solutions. It doesn't mean no solution though, right? It means every point on one line is also on the other line, and therefore there are solutions, but there are infinitely many. When there are infinitely many solutions, we don't need to describe the solution. We just have to say infinite solutions are there. Or if they talk about whether the lines are coincident, parallel, or intersecting, then your conclusion will be coincident. But what will happen if I solve it by using the elimination method? That's what we want to see. Okay, so let's clear this board. So our question is, what will happen if we solve a system of equation that represents coincident lines? X minus 2y equal to 2 and minus 3x plus 6y equal to minus 6. Okay, so if you're just, without paying any attention to what they look like, if you just think about elimination method, then we can determine what number to multiply by. What number should I multiply first equation by to eliminate the x?
3.
3.
3.
3, right, 3. So multiply the first equation by 3. 3x minus 6y equal to 6. We don't need to multiply second one by anything. Minus 3x, I'm copying it, plus 6y equal to minus 6. And when I add them, x's do cancel out, but the y's are also canceling out. Right side is also canceling out. I'm getting 0 equal to 0. That indicates that the system is coincident. The lines are falling on top of each other. I'm not getting invalid equation. I'm getting valid equation, but I'm not getting an answer for x or y. That indicates that they are both coincident. Now, when in the case of coincidence, sometimes, you know, if you're good in numbers, good with numbers, you can see that by looking at the equation. Can you see that if I multiply first equation by -3, I'm getting second equation? -3 times first equation is same as second equation. That's what happens when they are coincident. The equations are essentially identical. One is a multiple of the other. A product, some number times first equation is equal to second equation. That's when they are coincident. So sometimes you can recognize it just by looking at it. Okay, so the system is coincident. So if you need to use elimination method to determine whether they are parallel lines or coincident lines, we can do that. Simply use elimination method to solve. If there is one solution, that means the system is intersecting. If there is, if this method leads to a invalid equation, it leads to no solutions but invalid results, invalid equation, that will indicate that there is no solution and therefore the lines are parallel. If the solution process ends up giving you a valid equation like 0 equal to 0, but doesn't lead to any solution, that indicates system is coincident. So we can use this method to determine whether the system is, what kind of system it is. Okay, so I need you to do just one problem. I want you to do the second problem here. The warm-up exercise 5, second problem. Basically, you need to determine whether the system is intersecting, parallel, or coincident. That's the question. Go ahead and do it on your worksheet or notebook, whatever you have.
Are we doing number 1 or number 2?
Number 2. So is there a point of intersection?
Yes, 1,3.
1, 3. No, it's equal to 3. Is it 3, 1 then?
Yeah, it's 3,
Yes,
comma
it's
1.
my bad.
3, 1. Okay, point of intersection is 3, 1. So the lines are intersecting. So if the question is whether this system is intersecting, parallel, or coincident, your conclusion is intersecting. If the question was to determine whether the system is consistent, inconsistent, or dependent, then your conclusion is consistent. So the question, whatever the question is, you have to answer that using proper word. Okay, so moving on to substitution method. Substitution method would be basically another method for solving the system. So I'm going to explain using this example. What you do is you have 2 equations to solve to find the point of intersection. So example 9a, I'm doing 9a. To do this, let's copy the problem. 2x plus y equal to 5. Minus 4x plus 6y equal to 12. And I'm going to take that first equation, 2x plus y equal to 5, and solve for y. Solve for y means you isolate y by itself and have an expression on the right side. So I subtract 2x from both sides, then I get y equal to 5 minus 2x, or minus 2x plus 5. I don't care how you write it. But we solved the second equation for y. Now what we do is we plug in 5 minus 2x. Since y equal to 5 minus 2x, we plug that into the second equation for the y, into the second equation in place of y. So second equation becomes negative 4x plus 6 times 5 minus 2x equal to 12. Now you have an equation that has only x. So from this, we can find the x. Minus 4x plus, the 6 has to be distributed in, 30 minus 12x equal to 12. Minus 4x and minus 12x add up to minus 16x. And I subtract the 30 from both sides to move it to the right side. That gives me 30 minus 12 is 8 18 plus 18. So divide both sides by negative 16, x equal to 18 over negative 16, which reduces to 9 over 8 minus 9 over 8. So we found the x. So all you have to do now is plug this in for the x into either equation. In fact, it's easier to use this. We already solved for y, solved one of the equation for y. I can plug in this number for the x right there. So that gives me y equal to 5 minus 2 times negative 9 over 8. 2 divides the 8 into 4. So I have y equal to 5 minus 9 over 4. Okay, so I need to reduce that further, simplify the subtraction. So the common denominator is 4, so equal to 4. And this will be 20 over 4. So I get 20 minus 9. So that's 11 over 4. So we found the answer by substitution method. So substitution method means you solve for one variable, solve any one of the equation for one variable and plug it into the other. So why did I choose y to solve for? Why didn't I choose x? In the first equation, can I choose to solve for x instead of y? I can, but why is it a bad idea? Why is the y better to solve for than x? Anybody?
Is the x is negative?
Negative is not a problem. So let me.
It's easier with the
Why
y
is it easier? That's my question, basically. What makes it easier?
because you would have fractions.
Fraction, exactly. That's the key. If I solve the first equation for the x instead of y, then here it is. 2x. I'm solving the first equation for x. 2x plus y equal to 5. Solving for x, so moving the y to the other side, I get y minus 5. Dividing by 2, I get y over 2 minus 5 over 2. Now, you don't want to deal with that, right? Now you have fractions. So you can still work with this if you're comfortable with the fraction. You can plug this in for the x in the first equation, in the second equation. That'll lead to the solution, but you have to work with the fractions. So to avoid that, I chose the y. But if there is no other way, then you have to do it. So let's, for example, if it is 3x plus 2y equal to 7 and 4x minus 5y equal to 9, now we have no choice. We have to solve for x or y, one of the equations. In fact, elimination method is inconvenient in this case. It brings in fraction right up front. So, I mean, substitution method is inconvenient. Elimination method is convenient. We can still use elimination method. Let's say I want to eliminate y. Can somebody tell me what numbers I should multiply? First equation
You
by?
can multiply the first one with -4 and the second one with 3.
Yes, that would eliminate x. I want to eliminate the y instead.
Then you can multiply the first one with 5 and the second one with 2.
2, right. 5 and 2. Then if you add them, the y's will cancel out. So elimination is more convenient here than substitution, right? So you use substitution method only if it is convenient, if you have the choice. If the problem tells you, some problems may tell you to use elimination method. In my normal classroom exams, I do give you such problem, ask you to eliminate by using elimination method. Sometimes I say use elimination method. Sometimes some problems will say use substitution method. Now that I basically, I'm not going to be testing you that way anymore, because with the online test, I won't be able to ask you to type up all your work. It's too much typing. So therefore, you are allowed to choose any method you want to use. So when is the substitution method convenient? When it is very easy to solve for one variable. Look at this 9b. In problem 9b, the second equation is minus y equal to minus 5x plus 6. All I have to do to solve for y is multiply both sides by negative. Then y equal to 5x minus 6. I get that. Then I substitute 5x minus 6 for the y in the other equation. It's fairly easy. So it's fairly easy to solve the second equation for y. And that's when the substitution method is convenient. Otherwise, elimination is always the most convenient method. So almost always, elimination is the easiest method to use. And you're free to use whichever method you want to use. I have this warm-up exercise. It says solve the system by substitution method. Okay, so what variable would you solve and which equation? If you want to use substitution method, then you have to solve for one variable. Which equation should I solve and which variable should I solve for?
The first one for y.
First one for y, that's right. Then it won't bring in any fraction. So it will become y. It's fairly easy, but I'm going to just quickly go over that. I have 2 minutes. First equation, solve for y. I get y equal to minus 2x plus 5. And plug it into the second equation. Then I get 4x plus 2 times minus 2x plus 5 equal to 8. So 4x minus 4x plus 5 plus 10 equal to 8. And the x's are canceling out. I'm getting 10 equal to 8. What does this mean?
There is no
It means
solution, so
inconsistent.
Right, no solution. A system is inconsistent. Remember, when you try to solve by any method, if you are ending up with an invalid equation and not getting any value for x or y, that means the system is inconsistent, no solution. If it is a coincident system, then you will not end up with an invalid equation like this. You'll end up with something valid. And that means they are coincident. So there is infinite many solutions. Okay, I'm done. And we don't need to do these exercises. That's for additional practice. So we are finished. So your homework is, yeah, it's already up and it's due 10 minutes before the next class, which is 10 minutes before Monday class. Enjoy the rest of the day and the weekend. I will see you on Monday.
So wait, there's no quiz, right? I
Yeah.
thought there was a quiz on the 8th.
The quiz one is still due on Monday. Remember the quiz on the course information?
Okay.
That is still due Monday. And also you're supposed to introduce yourself on the discussion board. That is still due Monday. And this assignment is due Monday. Fortunately,
Okay.
you have 5 days to do all that.
Okay. All right. Thank you.
Okay, have a nice day and have a nice weekend. I'll see you all Monday.
Bye, Professor.
Okay, thank you. Bye.
bye, Professor.
Bye.
Bye. Thank you.
Bye.
Thank you.
You're welcome. Have a nice one.
You too.